Hello friends, welcome to Data Pandit. Today we are going to discuss about the lookup operations in Abinitio. How many different types of lookup operations are there in Abinitio? Okay, so that's where we are going to see how we configure the lookup components and how we call the lookup operation in ongoing graph or in any component. So before going to discuss about the lookup operations, what we will see how many ways we can uh, have a lookup operations. So today in today's video session, we are going to check about the normal lookup operations based on common key between the lookup file and the um, in the incoming data flow. And we have a partitioning lookup file wherein we have a data partition on some MFS system, and I mean the data are processed in a multi-way. Components are designed to perform in partitioned way, and so there we normally use the partitioned lookup file, and then there is an interval lookup wherein we have the part of the key is falls between two endpoints of the particular range. So in that way, we use the interval lookup, and there is a dynamic lookup operations wherein we load the lookup file in a on a on-demand basis. Okay, so that memory-intensive applications can be smoothly run. Okay, so these things we are going to discuss about. We are not going to discuss about the ICFF index compressed flat files. That is that lookup operation we are going to discuss in some other day. So in today's session, we are going to talk about the basic operations and the partition lookup operation, dynamic lookup operations, and interval lookup operations. So okay, so let's see the first simple example of a graph piece. Like, so we have input data sets, and then there is a reformat component and normalized component output data set. So this is a simple piece of graph wherein wherein we are calling the lookup operations. So lookup file. So whenever we have to join the two data sets, either we go to the lookup operations or we join the data set. Okay. So here we are talking about the lookup operations. So there are always the so lookup operations versus join operation. So let's talk about the lookup operation here, and then we will see how it is different from the join operation. Okay, so first we need to configure the lookup file component. So if you go to the component organizer, then we will see that there is a lookup file component. So there that we can drag and we can configure, or any file component. If you go to the description, and we will have a type to specify lookup file. So any file-based component will have a four labels like input file, output file, lookup file, or intermediate file. So in that you can choose the lookup file. Then it will, though in the record format section, we need to specify the what kind of metadata this lookup file will have, and the key. So what is the common key between the calling data sets and the called data sets, and the lookup file and the calling data set. So that key we need to specify. This is a basic configuration of a lookup file component. And then we call as a simply we call the lookup. Okay. So let's go ahead and see any maybe example how we do the lookup operation. So I have taken you know this small piece of code wherein I'm declaring the data. What is the record format of the lookup. So this lookup component will have a record format ISIN and account number, or maybe some description. So ISIN would be the common key. Let's say this is the key. Okay. And I'll break the lookup file component, and I will have I need to specify the path. So there will be three things: key, record format, and the URL path, where the actual physical data sets, lookup data set is residing. So these three things we need to configure as part of lookup file component. Okay. So now let's see. I mean, we will have this kind of record set in the lookup file component, and our ongoing flow is like this, wherein we are enriching the account, maybe the account data in the reformat component with the ISIN number and description. Okay. So just call the lookup function. This is the lookup. This is the function, and this is the label of the lookup. So we need to specify the label of the component, and this is the key. Here, so I am just taking a complete record set from the lookup. Then we can we can assign the different fields from that. Either you can if you want to get the one field from any lookup, then just call the lookup function. Let's say if I have to get the description, so let's think, you know, uh, the description, then just call the lookup and the dot description. I need to specify the ISIN. This is the key. ISIN is the key. Okay. So this is another way of doing it. Okay. So I'm just declaring the LKP type above. Okay, so this is exactly same as a lookup record format. Okay, and I have declared this, and I'm calling this and taking a whole data set. And here in the next, I'm specifying account number as a results dot account number, because we have account number, ISIN account number description, and in the second row I'm going to do this, and I am ending the reformat. Okay, out.isin isin description is equal to results dot description. So I have enriched my data sets, incoming data sets, and I have used the simple lookup operation. Okay. So why, what happens when call the lookup operation? So first, it will search, search the index for a lookup key value for a particular, let's say the IC number. It's going to search the particular index for that key. Then it will find the offset for that key value, and then it will locate the data for ISIN. In this case, it will be locating the data for account number description for particular ISIN, and then the record will be retrieved. Okay, and so so how we do, like, mostly what we do is, if we have to prepare the lookup file in Abinitio graph, then maybe we can prepare the lookup file non prepare the lookup file in phase 0, and the same lookup file can be referenced in phase 1. So first we need to prepare the. So whenever we call the lookup operation, we should not, lookup should not be updating at the same time. Then it will, result into the failure and synchronous data, because we are calling the lookup function, and we are also updating the lookup. So this both operation cannot be done simultaneously. So this should be in sequence. Okay. So this things needs to be taken care. Okay, and then we will talk about the partitioning. The lookup operations happens in in the partitioned partitioned processing. So let's say our things are, or graphs or components are working parallelly. So if MFS input data set, and then I have a reformat which is running at a parallel, and I'm loading into the S3 bucket. Okay, so I have to have same depth, partition lookup. So eight-way partition lookup. If I want to call that lookup from the reformat, so I should have that lookup also partition on the same way. Okay. So then I can call the lookup in the reformat in the same way, but there will be a little difference in the calling functions. So lookup underscore local I have to use. Okay. So if you look at the lookup example number three in the partition lookup case, I did not use the lookup directly. I use the lookup local, and then is the label of that, and then order ID is the key, and then address line number one. So if I order location, let's say I'm going to retrieve from the lookup, then address line one is the field in the order lookup. So I'm taking that and enriching my order location from the lookup operation. So why lookup? When we specify lookup local, so because my reformat is running in ATWay parallel, so if the data which is residing in partition number one, and I'm calling that lookup local, then the because my lookup also is partitioned on the same way, and partition one data would be loaded into the memory that time, and the lookup operation will be performed. It will not have to load the entire lookup. Okay, so to memory to utilize the memory in efficient way, so that's where we use the partition lookup. We should not have different depth in depth between calling the operations and the lookup file. Okay, both should be partitioned on the same way. So why it is required is the so the per process memory requirement will be lower. So whenever the reformat is calling, and otherwise if you do in serial way, then the entire lookup needs to be loaded into the memory whenever the lookup of lookup functions call the lookup file. But in partition case, only so that's that call partitioned data will be loaded into the memory, and the lookup operation will be performed. So if the component is partitioned across different machines, then total memory requirement for per machine will be lower. So let's say our lookup our graph is running on several machines. I'm talking about 8 ways. So we have 8 computers, 8 host systems wherein all the things are running. Per partitions are running on one partitions are running on 8 host systems. So whenever we calling the lookup operation, so the memory, in a way, memory requirement for each machines will be lower if you have same partitioned lookup operation. So in that way, the memory requirement would be lower for each and every machine. And conceptually, the cooperative system also, index partitions without having to create the index. It's inherently, in a way, it will create the index in its own memory, and in that way, the lookup operation would be faster. So whenever we So let's talk about the interval lookup, and then I'll come back. For the mapping things, I need to discuss the memory mapping concept here. So interval lookup is also it's good. It could be in partitioned way, or so it's a common concept among partitioned or non-partitioned or serial lookup operations. So whenever we have a let's say we have a data sets of some order processing, or maybe some account data sets. Okay, so that account data sets, in that we will have a account ID and then start date and end date. So if that account is attribute of that account is changing based on some particular date. So let's say from January to February. So for a particular account, the status is X, you know, or maybe the account has opened, and then after opening the account, then then there is another status B or status C and status D is happening, and the previous account is getting closed, and from the February the new account, the same account, but the new record into the, let's say, into the table is started. So it's a SCD type two scenarios wherein we will have, same account. Um, if I have to write here like A1, then let's say start date is what, 1st Jan 2021. 2021. SSD type 2 scenario, okay, for account details. And end date is, let's say, is ended on Feb 2021. Okay, start date is 1 Jan. Then the next, maybe the address has changed due to that. ADDR1, okay, for that particular account. So it will be starting from 15th Jan 2021, and let's say address is remained 19 Feb 2021, and ADDR2 address second, okay, and the same account, let's say after that it did not change the address, let's say. So then for 20th Feb it will be starting, and we will be closing, let's say, on higher date 12th of, let's say, December. Mm, okay, and my address is just 3, okay, ADDR. So this kind of situation we have, let's say, data sets. So now I need to make this data set as a, lookup, and I will have like lookup operations which will be calling this lookup, let's say account lookup, and I'm calling with account A1, and I'm calling as a today's date. Let's say I have 20th of May, 22nd May, or 20. So I need to specify my lookup file component, wherein whenever I specify the key, I would be specifying the ID and then start date interval top exclusive and end date interval bottom exclusive. So there is a options of giving these modifiers in the lookup component. Okay, so therein you can say that my start date is the interval top exclusive. Top exclusive in the sense of, so whenever we specify the date 22nd May 2021, and I need to look into these three records, right? These are the only three records that are matching with A1. So where I need to go? I need to go on the records where the range of start date and end date where my 22nd May 2021 is falling. Okay, then this would be the record. If the end things are there, I'm, let's say it's starting on 22nd May. Okay, then what's going to happen is, so it's starting date top exclusive, so top would be excluded. Okay, then, okay, let's say it's coming as an end. Okay, 22nd, 21st, maybe 22nd it is going to May 2, and 23rd May from tomorrow. It did not happen actually, so it's not an perfect example there. So let's be it like it. Okay, so let it be in the same way, and so my 22nd May 2021 will falling between here. So my this this record will be retrieved. If I have to take the address, then this address 3 will be retrieved. Okay. So this is the concept of interval lookup. So let's go back to the memory mapping thing and the lookup operations. Okay, so I was talking about the memory mapping. So whenever we have these lookup operations, then some kind of memory mapping will be done. So okay, memory mapping in the sense of the internal understanding between the components. Let's say the lookup is called by many components, or in the partitioning many components in the serial way. and then the single lookup can be shared among these two reformat or probably many more reformats or many more other components. So this memory mapping is a kind of understanding in operating system, so that we could utilize the same copy of lookup file in different different locations or call different calls coming in from different parts of the graph. Okay. And in partitioned processing, so the same, look, if the all the partitions are residing in the same host, let's say my operating in the same local host, then the memory mapping will be achieved, and same local copy can be shared among different partitions of the reformat component, let's say. Okay. So, but in the case of whenever the file is remote, okay, the lookup file is remotely placed in some other computer. It's not in the running host. Then this memory mapping things cannot be achieved. Or if the lookup file is maybe the mainframe data sets, then also it cannot be achieved. Or if lookup is in HDFS system sitting on some other HDFS system or a cloud, then this memory mapping cannot be achieved. In that then the memory overhead would be there. If we want to achieve the distributed computing, then this memory mapping we have to leave it. I mean, we are compromising with the memory mapping process. Okay. So the layout of the depth in the partitioning thing has to be equal to the depth of the lookup file. Okay. Now let's talk about the dynamic lookup. Okay. So dynamic lookup. So So in simpler lookup operations, what is the disadvantage and what are the disadvantages? Advantage is we if we use the files like we have in join, so files will have a different memory requirement and will be constant memory requirement. But in case of lookup operations, and we can have in-memory operations and the data loaded in the in-memory, and if the calling component, if it needs some data and it's available in memory, then the operation would be faster than the components call getting the data from the hard actual disk. So from the memory and in memory processing actually while we do the lookup. So this is an advantage here. And if we talk about the dynamic lookup, but dynamic lookup versus normal lookup. So dynamic, so whenever we have a lookup operation, then there will be some address space requirement. So before processing of the graph, there will be some physical location where the data would be residing. So then and the indexing and the other address space for the lookup operation has to be there. But in the so to avoid that, there is a dynamic lookup. So as and when we require the lookup file, lookup data sets, then we can call the lookup load function and we can load the particular lookup then and there, and we use that lookup data and then we can unload the lookup. Okay, so in that way we can utilize the memory requirement for the particular component in efficient way. So this is the advantage of dynamic lookup. Okay, so you can call the lookup as and when require, and you can call the, different lookup functions. Lookup create. You can create the lookup dynamically. So in normal way, I mean, we have a lookup template function and lookup template component available in our component organizer. We configure that lookup template component. We label it and we supply the keys and the record format. But otherwise, we can call the lookup create, and we can create the lookup dynamically. And then if we want to add the elements, and that also we can do. So there are two advantages of dynamic lookup. We can dynamically add and delete, or update the generations. It's called a generations of generation of records. So those things we are going to discuss as part of ICFF on some other day. But as part of this dynamic lookup operations, we can so you should understand that we can modify the lookup while running the graph. So let's say my lookup, I have some requirement wherein lookup also is getting updated or appended or modified, and I need to use the lookup to enrich my data, in the same probably in the same graph, or the same component itself. So what I can do is I can create the lookup through using the lookup create function, and I can prepare my data set, and through using the lookup add function I can add that element, and further I can unload the lookup to release the memory, and then again I can load that lookup, and I can use that updated lookup. Okay. uh, in a similar way. So let's look at how we can utilize the dynamic lookup. So here is one example wherein dynamic lookup operations, dynamic lookup object I can declare. So lookup identifier type is a it's a lookup kind of type. So whenever we call a lookup not loaded, we'll return the lookup identifier type. So if my lookup is not loaded, then I have to load the lookup. So my lookup load. So this function is lookup load basically. I have to call lookup load this. Then I need to provide a data path. It's the same path, where our physical data set is, residing. And in partition way, if it is there, then this partition path, dollar path, lookup file path, okay. And we will have index path. So we are going to talk about indexing and all in the next session when we will talking about the ICFF. And then there is a lookup template, the label of the lookup file, and then load behavior. So load, there are many load behavior. Lookup load up, updatable. Actually, it's an updatable. Okay, appendable, updatable, and so there are many operations actually. So there are 4 to 5 operations wherein load behavior will be distinguished. Okay. So, in short ways, I mean, this lookup load, we can use, we can have a more control of our lookup operations. Whenever we need, we can unload or load. We can amend or append the record, and we can release the memory as and when required. Okay. So there are few functions which can support lookup create, lookup add, lookup load, lookup unload. So these kind of different functions are available, which